if you have anything in mind, because actually I just concentrated only on this little group of problems with degrees, and today I want to continue to talk about this section that deals with another way to present angles using totally different approach. So that'd be exciting. So anyways, in this section, I had to take a look at the conversion. 9 minutes, I'm gonna turn into 9/60 of degrees. And 9 seconds, I'm gonna turn into 9/60 of 60s, which is 36 over 100 of degrees. So I should put degree signs on the bottom, on the top, not on the bottom. So it looks like we're gonna have this pieces added together because we say 9 degrees and means plus 9 minutes or 9/60, and also added with 9 of 3600s. So let me get for the scientific calculator, just start typing it in Google and get that first selection that I will always use here, called Desmos, and just enter those numbers carefully. So I go 9 plus this 9 divided by 60, and then also add it with 9 divided by 3600. And that's all in terms of degrees, so I don't need to worry about placing any symbols, just write down this number. So it's 91525. So if somebody decided to round, that's also fine. So this is our answer for the quiz that we had last time. If someone missed a quiz, I accept late work. You can send me your response, or just take any exercise similar to this one and do pretty much the same thing. So degree is a special measure of the angle if you make a break by 360 pieces, this whole rotation around this center point, this point 0, 0, or the origin. So what else they're talking here is another way to measure angles using the unit circle. Unit circle means a circle with a radius equal to 1. So the circle will be passing through point 1 on the x-axis, point 1 on the y-axis, and here will be the -1. So this is so-called unit circle. It's centered at the origin, point 0, 0. And we measure angles going along the x-axis. And the way we measure them, we utilize the radius. So if unit circle has radius 1, so if you decide to walk along the circle circumference by the same exact distance, which is also going to be 1 radius, then the angle produced is going to be measured as 1 radian. And that's pretty different with degrees. Degrees, I guess, is kind of intuitive. Degrees, minutes, we used to deal with clock and get those numbers from it. But here, we actually measure it using the radius of the circle. And we measure angle a special way. We take so-called arc. So it doesn't have to be a measure of 1. It could be pretty much the same measure for everything. In fact, if you recall, the circumference of the circle with radius r, that measures as a 2 pi r, remember? Whenever you deal with a circle, there are 2 formulas associated with it. One is the way around the circle. It's like an analog of perimeter. So you go around the circle, and if you go all the way around, it's like 360 degrees, but it's also 2 pi r. Well, in a case if radius is equal to 1, if it doesn't have to, but if it's equal to 1, then you get circumference, which is 2 pi times 1. And that's what makes this 2 pi, which is way around the unit circle, correspond to the angle equal to 360 degrees in measure. Remember, full rotation, 360. I don't say it's equal because on one hand it's degrees, and on the other hand it's just the way around the circle, so it's kind of different units, but they are giving you the same exact measure of the angle. So if you have the half rotation, then we call it as pi. And that's, I guess, a key observation in terms of those radians. If you divide both sides by pi of this statement, so you get one so-called radian, which is the same as 180 divided by pi. That's how they treat it, even though it's not the same, but we say it's analogous. So we should have put like wiggle, so you say it's not really the same, but technically in this section we're gonna treat it as if it was the same when we start to convert our angles between the degrees and the radians. So let's say if I try to take a look at exercise number 17, the first one here that deals with this pi representation or radians here. So if you take 3 pi divided by 4 and try to draw this angle. So how can I possibly do this? Well, take a unit circle. So we're going to use unit circle here. So radius is 1. And then I need to take pi over 4. So if my angle pi corresponds to 180 degrees, then the fourth part of it will come out by dividing both sides of this statement by 4, right? So if I want to see the analog to pi over 4, then I'm going to divide 180 by 4, and that's going to be 45 degrees, right? 45 degrees or a quarter of a half rotation, so it'd be something like that. So I would say this is pi over 4. In fact, the way we treat it is it's way along the circle. It's like arc. People call it as arc. So that's the length. If you walk around the circle to the place where 45 degrees angle intersects the circle and stop at that stage. So analogously, then I can get another pi over 4, and then finally 3 of these pi's over 4. That will correspond to actually taking my 45 degrees angle 3 times, right? Because I take 45 degrees once, so this is equivalent to 45. And then twice, so I get 90 degrees. And then another time it'll be 135 degrees, right? So it turns out that people could get this faster, but algebraic way, not intuitive way, if they want to say that if I deal with 3 pi over 4 times 1 radian, because that's measuring radians, what I can do is replace that 1 radian with this degree notation. So I will turn this into 3 pi over 4 times 180 over pi. So notice that the pi will go away and we'll have degrees appearing, and the answer better be the same. And notice that's indeed it's 135. They say, really? Well, put in a calculator. I just did this arithmetic here down below. Turns out that this is algebraic method to convert, which is totally not intuitive. People just remember to multiply by 180 over pi, and this way this pi will cancel. So pi has to be in denominator. And probably if you go to the tutoring lab, that's how the tutors will show it to you. And I guess that's perfectly fine way to do problems for conversion. You can convert backwards, like let's say in exercise number 37, for example. So if you try that here, 37, that's was 240 degrees. So I can again do it both ways. I'll do it intuitive way first, and then we'll actually see how this could be done faster, just using algebraic way of conversion. So 240, first of all, I'm gonna try to make a picture of this angle. And notice that 240, so it deals with 120 taken twice. Why do I care about 120? Well, because that's dividing 2 pi by 3, right? So if you look at, or whatever way you prefer, some people say how many popular angles such as 90 degrees consist in here or something else. So you can say 90 degrees. If you take it twice, it's going to be 180, right? And then you need another 60. So basically, if you break this into 3 pieces, then here will be a 240. So basically, this is 90, 90, 180, and another 60, right? So this is how I can think of 240 degrees. Let me put that somehow here. 240. Remember, positive angles always go counterclockwise, right? 240 degrees. And then how can I possibly convert this to those radians? Well, it turns out that I can also imagine myself a full rotation, which is 360, that I break into 3 pieces. So we get 120, right? And if I take 120 degrees twice, so that'll be 240, right? In other words, if I have this 3 pieces that I cut my 360 into, and then take 120. So I guess you don't have to think of it this way, but just an example how you can intuitively get to this 240 degrees. And since 360, which is 2 pi, I divide by 3, right? That's what we just did. So I took pi over 3 and then another pi over 3. 2 pi over 3. And again, since it's in radians or in radius measures of 1 here, so there'll be taken 2 pi over 3 over 3, this radius. See, that's not very intuitive. So what is 2 pi over 3? Well, you can put this in a calculator and actually get this. But again, what I can do is show you without making a picture how I could utilize this only formula that I guess we care about in here. So if I rewrite it as pi, which is equivalent to 180 degrees, So now I want to turn 1 degree into the radius or radians. So I divide both sides by 180, right? So in other words, if I have 240 degrees, let me write it down again, then what I could think of is taking this 240 degrees times 1, or 240 times 1 degree, just like in the previous example. And then instead of 1 degree, I'm going to put this fraction, so it'll be 240 times pi over 180. And now it's already going to be radians, because this kind of degrees and degrees are going to be just canceled somehow, right? So now we're going to actually simplify 240 and 180, right? And looks like I could divide both of them by what? By 10, right? Zeros will disappear, and then 24 and 18 looks like it's 6. So in other words, if I divide by 60, I'm gonna get 60, maybe even by twice 60 by 1. Okay. So just how do you produce this piece? Looks like I got something that I should be a little bit more careful with, right? So how would you cancel this? So I get 0. I want to get a little bit more room. That's what bothers me. So if I take the zeros out, right? And then I have to take another 6. So 3 will be in denominator, pi will be here, and then it's a 4 pi over 3. I say, Alex, why do you put 2 pi over 3? Well, because 2 pi over 3 is here. We divide 2 pi by 3, but then I need to get another same angle. So it'll be like twice 2 pi over 3. Right? 2 times 2 pi over 3. And that's how we get that result. So I should be careful. So 2 pi over 3 is that one, but twice will be that one. And if you take it 3 times, that will be exactly 2 pi. So I guess the algebraic way to convert gives you the answer for sure. So that's probably the best idea to approach. And that way you can convert pretty much anything. So let's say if I try one more here, exercise number 53, to do another little conversion. So let us try to get a little room here. So I guess my key formula will be highlighted in here, but it's actually the important thing to realize that if you have the right assumption with degrees, then what you get is that blue underlined statement. So instead of radian, you get degrees. Or if you want to write something in radians, then you get rid of degrees by turning it into pi over 180. So either one is going to be always utilized. So let me get this utilized in exercise number 53 here. So my goal is just to do some problems and get used to all these ideas. So in 53, with pi over 12, I have to turn this, looks like, into degrees. So I write this times 1 radian. That doesn't change anything if I turn it into 1. And then 1 radian is 180 over pi. So I go pi over 12 times 180 over pi. So I don't really need to even bother making any pictures if we have algebraic way. But geometric gives you intuition, so you can better see why these formulas are applied. But I guess you don't really have to. Notice you can divide both by 6, right? So it'll give you 2 on the bottom and 30 on the top. Degrees is still with us, and that's actually 15 degrees. So could be technically any number of degrees that you produced from here. And that's the way to go. So let us try.
Professor, I have a question. Do you always use the one radical? Do you always times it by the one radical?
Do I always use which one? Could you please say it again? Do I always use what?
For number 53, that it has pi over 12 times 1 radius.
Uh-huh.
Do you always use the 1 radius?
You don't have to put 1 radian. I was just trying to explain you why I replace this with 180 over pi.
Oh, okay.
I know
Okay.
some people never write 1 radian. They just automatically multiply by 180 over pi. But the question is why? Well, the answer is because you can write it times 1 radian. I guess
Oh, wait. So you're saying that pi over 12 times 1 radian is the same thing as pi over 12 times 180 over pi?
yes.
Oh, okay. Okay, my bad. Sorry.
No, you're having very good question. That's good. So that you're actually clarifying it, because if you start to understand this, you will feel very good about any science class that you take with all of those little formulas, because all you do is just see how the units related to each other. For example, when you convert, say, feet to inches or inches to feet, you do exactly the same thing. Or if you're taken physics classes, there'll be some other units that you convert one to the others, and in other science classes, there's always going to be some kind of relationships between various units of different names. I just don't want to name them, but it goes exact same way for all of them. So if you have pi over 12, notice that pi over 12 means it's in terms of radians because there is no degree signs. And that's why I can write it as pi over 12 times 1, because it doesn't change anything of these radians. But then I use the formula, and that's the key part. So 1 radian is actually the same as 180 over pi. And that's why this conversion actually goes through, because instead of pi over 12 times 1, you go times 180 degrees over pi. See, now it's already in terms of degrees. So a radian was taken care of, was replaced with this degrees. And that's what I need. And that way, you go ahead and simplify. But
Professor,
yes,
is there going to be a quiz today? Because I have to
yeah,
log off and log back on.
you can take the quiz always later and email me your answer, and that's fine, because I make a recording of each lecture, and then I email you the link to that recording, so you can check your email in a few hours. It's not
Okay,
right
thank
away,
you.
because
Okay, something important just came up and I don't want to be marked absent.
I don't mark anybody absent. I don't really worry if you're present on Zoom or not. You may not be able to, that's fine. All you need is just to watch the recording. Now, sometimes people send me a question, Alex, where is the recording? Well, I need to wait for it because it takes Zoom for some reason to convert it 2, sometimes 3 hours. So I wait until it comes up, and then when I see it's ready, then I send you the link. I can send you link of lecture earlier, but then people click on it and say, where's the recording? It doesn't work. Well, because it takes Zoom a little time. That's why I'm trying to send you this link a little bit later. And if it happens, I sometimes send it early and you don't see, you click on there's no recording, it means you need to wait a little bit because it takes the program. So that's, I guess, technical part, just making sure you realize that.
Okay, Professor. Thank you so much for
You're welcome.
understanding.
Professor,
Yeah,
what's the quiz under?
Can you say
Where's the
what?
quiz? Is it just the homework assignments that we've been doing?
Quizzes, declare a quiz. So at the end of this lecture, so if you be with us, you will hear say, okay, so now let's do the quiz. So I'll tell you, the quiz is exercise such and such, and it'd be at the end of the lecture. So we already had first lecture last week, so you can check recording that I emailed. And at the end of that first lecture, there was a quiz, so you can see what was for the quiz. And you
Okay.
can, and
And
it
just
pretty
email
much,
you the answers, or
what's
how
that?
do we? What do we do for the answers for the quiz?
You put them in the chat or you email me.
Oh, okay, got it. Thank you.
So those quizzes I usually give at the end of the class meeting, pretty much on all classes. Sometimes I don't give a quiz, but usually at the end of a recording of lecture, in the case if somebody misses the lecture or part of it, that's fine. That's why I give you recordings. I email those recordings, so you can always check it out and see what we had for a quiz and what we had during the lecture. In fact, before the quiz, I always do similar exercises that will help you to actually take that little quiz. And that's why for the last quiz, I think everybody did it absolutely correctly. Because if you just, yes, please, question.
Yeah,
Sorry.
Prophet. Okay, Professor. Yes, thank you. I'm gonna I'm gonna tell you what I'm doing for the homework. I am doing like every session that you explain. I'm choosing like 2 examples
Good.
and writing on a notebook. Do you think
Very
that is
good.
a good idea?
Yes, it's very good idea. That's the
And
way to go.
I specify what page and what exercise number is for every day. I can give you in the midterm. I can send you everything. Okay.
Yes, yes, that's perfect.
Professor,
Thank you. Thank you so much, Professor.
Yes, yes, of course.
where do we do the homework?
Homework is due when we have our midterm. Midterm will be, I believe, 16th of October.
Okay, but right now we don't have any homework. It's just, the lecture.
Right now, you do have homework, but you don't send it to me. So you do homework, but just be patient. Don't send it to me yet. You send it to me when we have the midterm. The whole thing.
homework is the notes that you take in class.
Yes,
Okay.
exactly.
Thank you very much.
Yes. Or if
Professor,
you like,
I have a question about number 53 again.
uh-huh.
Sorry, I got into class late, so this is like my first question that I'm really seeing. How did you get to 30 degrees?
I did a little bit of arithmetic. I canceled the pi's. So if you look at this expression produced, so you cancel pi because you multiply and divide by pi. And then I divide by 6. So here I get 2, and I divide 18 by 6, I get 3. So it'll be 30 divided by 2. So you simply
And where did you get the 6 from?
6. So when you
Yeah.
have 180 divided by 12, what you can do is you can factor. So 6 times 2 is 12, and 6 times 30 is 180. Some people can say, Alex, I wanted to factor it with 12, so it'll be 12 times 15. You can factor it any way you like. That's the point. It's factoring of numbers. That's arithmetic. So you just
Okay. Thank you.
so
Sorry,
practice
Professor,
to factor.
what's the website for the homework? I can't find it right now.
Oh, the link to the textbook, I can share it with everyone. In fact, I have this in that little YouTube channel. I put this in the syllabus. So the link to the YouTube channel is there. And I highly recommend that you subscribe to it. So this way you will always have all of the lectures with you for this class.
Perfect. Thank you.
So I'm going to, but at this stage, just click on this link that I gave you. And this way you will be able to see what we did. In fact, I sent you these lectures by email every time after class. So this lecture I will send in a few hours. But
Okay.
anyway,
Okay. And you just assign the page number at the end of class, right? With the questions to do.
I don't assign the page. I already wrote in the syllabus that what we do in class, that's your homework. So if you
Okay.
don't know what page it is, just click on the link of that video and you will see that page is gonna be right there. So all you need is to look at the recording and you will clearly see the page. It's right here.
Great. Thank you.
Mhm. So yeah, the book is always opened in front of everyone in the recording. So you can just start this, watching this recording, and you will right away see what page we're working with. Okay, so let's try another one. I guess for this exercise set, I'm not gonna move any farther for this section, so I'm not gonna worry about those exercises because again, it's something that may be worth to revisit a little bit later because it has all these unit conversions. So it's miles, there are inches, all these little things that some people may not like because they're more related probably to mechanics than to pre-calculus. So we really concerned here with this radians and degrees. So I don't want to worry about the other units at this stage because it brings probably a little bit of confusion. So let me try one more conversion of these just to show you they're all pretty much same. How about if I take one with a negative sign for a change? Let's say, how about exercise number 58 that has minus 3 pi over 4. So whenever I produce the answer, it's also going to be with a negative sign. So I have this minus 3 pi over 4 to turn into degrees. And just like in the previous exercise, it's going to be 1 times radian. And instead of 1 radian, I'm going to utilize this little formula. I just messed it up so bad. So formula is here, nice and clean now. So this is times 180 over pi. And that's exactly what we did in the previous example. So all problems are really same. You're multiplying by 180 over pi or by its reciprocal. So if you need to get degrees, then 180 degrees needs to be in your numerator. And that's here. I just want to write it a little bit more carefully because it's kind of hard to see that it's 180. So 1 and then 0. You need to practice to write 0. And then there is a little like 0 with 4 degrees. And then we simplify. So how do I simplify? You don't have to simplify it exact same way that I do. You may prefer your own way. But what I can see, it's 4 times 45 for 180. If you right away don't see it, you can say, Alex, I see it's 2 times 90. Okay, so put it 2 times 90, then instead of 90, put 2 times 45. But the point here is that now I can cancel this 4 with that 4 and the pi with that pi. So 180 is gone. Now only 45 degrees left from it, right? So what else is here? Well, I see minus 3 from the first and then 45 degrees from the second fraction. So I multiply the 3 by 45, get 135. And the minus sign, of course, is present here with us. So I guess that's the way to go here whenever you want to turn this into degrees. So maybe you can try number 47 exercise. I think it's very, very similar question. So do number 47 for the quiz. I can write it here for you. This is turning pi over 3 into degrees. So how many degrees you think it is equal to? And you could either go intuitively, or you could go just the way I did here, multiplied by 180 over pi, because the answer is the same. And all I need is just your answer. So just put the answer in the chat, and that'll be all we need for today. Thank you for coming. Bye-bye.
Professor, what was the problem again?
Exercise number 47. 47. I wrote it on the lower corner on the right side.
Thank you, Professor. Professor,
Yes.
another question. It's okay if we can write your notes in our homework, right? No problem.
Yes, yes. That's what I recommended.
Like the homework basically is the notes.
Mm-hmm.
Okay, thank you so much. I already sent the quiz. Thank you.
Very good.
The class is finished?
Uh-huh.
Okay, thank you. Have a great day.
You too. Thank you.
Thank you, Professor. Bye.
Bye-bye. Thank you. Bye-bye.
Thank you, Professor. Have a good day.
Bye-bye. Thank you.
Hello, teacher. Um, I barely joined the class on Friday, so I missed Tuesday and Thursday. Can I receive the Zoom for those days?
Good. You
Oh,
need
you
to
need
receive
to
it?
receive it?
Huh?
Do you
Do
need it
you
or
need it?
you receive it?
Um, well, I do want to like catch up because I did join your class late, like on Friday. Like I had a different class, and then I dropped that class for this class.
I don't
I
understand.
don't understand.
Do you
Do
need
you need
Zoom?
Zoom
Do you need to receive it or you have
or
it?
you have it?
the Zoom link for
Yes.
the first lecture, I don't have it.
So
So
please put
please
your
put your
email
email
into Zoom
into
chat
Zoom chat.
Okay.
and just
And
write what
just
you
write
need
what
to
you need
receive.
to receive.
Huh?
Okay, just put your
Put
email.
your email.
There.
Professor, I sent my answer. Can you check if it's the right like one, if I got it right?
Yes, it's right.
Thank you. Have a good day.
Bye-bye.
Professor, what about
Yeah.
mine?
Yes.
I was right.
Say it again.
Mine, silence.
Yeah,
My
everybody
answer.
got it right. Good.
Okay, have a good day, Professor.
Bye-bye.
Professor,
Yes,
am I okay with my answer too? I just want to make
Yes.
sure. Thank you. Have a good one.
thank you.
Hi, Professor. I just submit my answer. If you could please check it.
Yes, they're all good.
Thank you.
So once again, we do quiz exercise number 47. So if you can put the answer in degrees in the chat, that's great. Thank you. Okay, no problem. That's fine. Take your time. You can email it to me later. Yes. You're welcome.